Good morning, students. Last class we have done with Rutherford's scattering experiment, the observations and the conclusions drawn by Rutherford, and on the basis of it he gave the Rutherford's model. Now this class we will be doing with the drawbacks of Rutherford's model. Now Rutherford's model resembled the solar system. According to Rutherford, the positively charged nucleus is present in the center and the electrons revolve around it in circular paths which were called as orbits. According to him, this was the model of atom. Now, according to the electromagnetic wave theory, given by Maxwell, any charged particle, electromagnetic wave theory is a very important theory of physics. Slightly in detail we will be doing it in this chapter also. But what does electromagnetic wave theory say? It says that any charged particle, maybe it is positively charged or negatively charged, but it should be charged particle, under acceleration, if that charged particle is moving and its motion is accelerated, will continuously lose energy. Energy in form of radiations. Again, I am repeating. According to electromagnetic wave theory of Maxwell, any charged particle, it may be positively charged, it may be negatively charged. If its motion is accelerated, then it will continuously lose energy in the form of radiations. Now let us see. Electron is a charged particle and it is moving in circular orbits. Even if we consider that it moves with same speed, suppose I consider that the electron present is moving, I consider only one electron, suppose. This electron is moving only with same speed, its speed is not changing. Then also its motion is accelerated. How? You know that acceleration is v minus u upon t. I am saying that it is moving with the same speed, but I am not saying it is moving with the same velocity. You know, speed is a scalar quantity and velocity is a vector quantity. It depends upon direction. And when the electron is moving in a circular orbit, its direction of motion will keep on changing. It is moving this side, then this side, then this side, upward direction, downward here, upward here. So its direction is changing. If the direction is changing, its velocity will change and therefore its motion is accelerated. So I consider that the motion of this electron is accelerated, so it will continuously lose energy in form of radiations. If it loses energy, then its speed will decrease. And if its speed decreases, the nucleus, which is positively charged, will attract the electron towards it. And electron by spiral motion will come closer and closer to the nucleus and ultimately fall in the nucleus. This cannot happen, otherwise the atom will not exist. So Rutherford's model, what is the drawback? He was not able to explain the stability of an atom. Why? because according to him, electron is moving in circular orbits, and according to Maxwell, if the motion of electron is accelerated, it will lose energy, and when it loses energy, the nucleus attracts it, so it comes closer and closer, closer to the nucleus and ultimately falls in the nucleus. This is not possible. So he was not able to explain the stability of an atom. The electron will fall, if I consider his model is correct, the electron will fall in the nucleus by spiral motion in 10 to the power minus 8 seconds. It will not take 1 second even. You can just imagine 10 to the power minus 8 seconds, and this electron will fall in the nucleus. So this was the most important drawback of Rutherford's model, why it was rejected. Other drawbacks are Rutherford never gave any idea about the number of orbits which are present and the distribution of electrons in these orbits. That means how many electrons are present in the first orbit, what is the energy of the electron in first, second orbit, how many electrons are there, what is the energy, what is the gap between the orbits, nothing. So Rutherford did not have any idea about the distribution of electrons, the energy of electrons in different orbits, anything. So Rutherford's model gave no idea about distribution of electrons, in different shells, in different orbits, and their energies, the number of orbits that are possible, the distance between them, etc. So on these grounds, Rutherford's model was rejected. And after Rutherford's model came the Bohr model. But before Niels Bohr gave his model, there were several important discoveries that were done, which led Niels Bohr to give his model. The first, we will be doing all other discoveries, and then we will come to the Niels Bohr's model. Thank you.